check out all these circles. What we're doing here is we're making a fractal. We start off with one circle like that, and then we draw 3 more little ones in there. Then we take each of these small circles and we draw 3 more circles in those to get to stage 3. And we go on and on and on. And the question asks us, how many circles are in stage 5? Well, that's easy. All we have to do is draw stage 5 and count the circles. Here we go. Put 3 little circles in each one of these. 3 little circles here. 3 little circles. This is a bad idea. After I get done drawing all these little circles, I have to go through and draw 3 more little circles in each one of those little circles. And there's no way you're going to watch all the way through that. So let's find something smarter to do. Let's look for a pattern. All right, we got 1 circle there, and there we have 4 circles. And then over here, well, just right in there is 4 circles. There's another 4. There's another 4. That gives me 12. And then the big one gives us 13 in stage 3. So we've got 1, and then we've got 4, and then we've got 13, and then we've got 1, 4, 13. I don't know what's next. That didn't work. All right. I got a sequence. It starts 1, 4, 13. And I'm stuck. And, well, when I'm dealing with sequences that I don't quite understand, and I don't quite understand this one yet, sometimes I like to look at the difference between each of the 2 terms, and that helps me understand sequence a little bit better. Let's try that here. We start off with just 1 circle. And then we add 3 more. We add on 3 more circles to get from the first stage to the second. To get to the third stage, we take each of these smaller circles and we put 3 more circles in them. Like the 3 circles we put here. So we're adding on 3 times 3. We're adding on 9 more circles. And then to get from stage 3 to stage 4, I take each one of these smaller circles, and as we see here, we put in 3 more little circles. So I had 9 little circles that I added in stage 3. To get to stage 4, I put 3 more circles in each of those. I add on 3 times 9, that's 27 more circles. And now we see the pattern. Those 27 new circles that we added into stage 4, to get to stage 5, we're going to put 3 more circles in each of those. So we're going to add on 3 times 27 is 81 more circles to get to stage 5. And now we can just add this up to figure out how many circles there are in stage 5. 1 and 9 is 10, 3 and 27 is 30, 30 and 10, that gives us 40. Add the 81, that gives us 121. Now that addition right there wasn't very sporting. I'm going to show you something else that's pretty slick that you can use on summations that are longer. You're multiplying by something other than 3. Check this out. What we're doing here is we're multiplying by 3 to get to each term. 1 times 3 is 3, 3 times 3 is 9, 9 times 3 is 27, 27 times 3 is 81. We have a name for this. It's called a geometric series. It just means we multiply by the same thing at each step. Now if we look back here at this problem, the way we figured out our pattern and solved this problem was we looked at the difference from each step to the next. Going from 1 to 4, the difference was 3. Going from 4 to 13, the difference was 9, and so on. When we're looking at a geometric series, what we want to think about here isn't the difference, but the ratio. The ratio of this term to that term, this term to that term. That ratio is always 3. So we multiply by 3, multiply by 3, multiply by 3. Sounds like a good idea. Let's multiply by 3. We'll take this whole sum, multiply by 3. 3 times 1 is 3, 3 times 3 is 9. 3 times 9 is 27. 27 times 3 is 81. 81 times 3 is 243. Now we see a lot of terms we've seen before. We're all set up to do a massive cancellation. This is really slick. What we're going to do here is we're going to subtract. We're going to start from here and subtract all of this down here. Now over here on the left-hand side, we've got 3s minus s. That's just 2s. Now look at what happens over here. 3 cancels with the 3. 9 minus 9, that's 0. 27 minus 27, gone. 81 minus 81, out of here. All we're left with is 243 minus 1. That's 242. So I've got 2s equals 242. We divide by 2, and we get s is 121. So we got 2 strategies we just learned. Look at the difference between terms and sequence, or look at the ratio between terms and sequences. And sometimes that'll help you solve the problem. Let's try another one. Okay, we've got to sum of the first n terms of a sequence is given by the formula. They gave us the formula this time. That's awfully nice of them. And then they give us an example here, but make sure we know what we're doing. But we know what we're doing here. What we're looking for here is A6. We're looking for the sixth term in the sequence. All we're given is the formula for the sum of the sequence. I thought we knew what we were doing here. I thought maybe we don't know what's going on here. I'm a little confused. Now, when I get a little confused, what I like to do is play around a little bit. If I just sit and stare, it's not going to solve itself. So I'm going to mess around a little bit, see if I can understand the problem a little bit better. I'm going to stick some numbers in here and see what happens. So an easy number to put in is 1. I'm going to put in 1 for n, and we're going to get S1 equals 1 squared plus 4 times 1 plus 8. So 1 plus 4 is 5 plus 8 is 13. So the sum of the first 1 terms is 13. Sum of the first 1 terms, that's just the first term. So now we know that the first term is 13. Oh, we want the sixth term. Well, at least we found the first term. We'll keep playing around. I still don't see it. So put in 2 for n. Now give me 2 squared plus 4 times 2 plus 8. 2 squared is 4 plus 4 times 2 is 8. I guess it's 12 plus 8 is 20. And that's S2. That's the sum of the first 2 terms. And we know what A1 is. A1 is 13. So A2 has to be 7. So this tells me that A2 is 7. That's still not A6, but we were able, going from S1 to S2, we were able to figure out what A2 is. So that means if we look at S3, we should be able to figure out what A3 is. And we don't even have to do any computation because they gave us S3. That was awfully nice of them. S3 is 29. That's A1 plus A2 plus A3. And we substitute in A1 and A2 into here. 13 and 7 gives us 20. We already knew that. We already knew that A1 plus A2 is 20. We had that right here. Didn't even really have to know what A1 and A2 are. We just needed to know their sum, which is 20. Put 20 in there. 20 plus A3 is 29. That tells me A3 is 9. Now, I could keep going like this. Put down S4, figure out what A4 is, put down S5, but look what we did right here. We didn't actually have to figure out what A1 and A2 are. We didn't have to figure that out because we're given their sum. We just needed A1 plus A2. Ah, I see. Like if we were going to go on to S4, check this out. S4 is the sum of the first 4 terms. First, second, third, fourth term. Let's compare that to S3, the sum of the first, second, and third terms. All right? Check out what happens when you take S4 and subtract S3. Cancel the first term, cancel the second term, cancel the third term. You're left with the fourth term. So to get to A6, we start with the sum of the first 6 terms and subtract the sum of the first 5. Sum of the first 6 minus the sum of the first 5. All these over here will cancel out and we'll be left with this one. Here's what it looks like when it's not just fingers. We're going to start off with S6. That's A1 plus A2 plus on and on and on. A5 and then A6. We're going to compare that to S5, which is just A1 plus A2 on and on and on up to A5. And then we're just going to subtract. We're going to subtract here S6 minus S5. That's what we'll get over here. And look at what happens on the right-hand side. All these fingers go away. A1 minus A1, A2 A minus A2, A3 minus A3, A4 minus A4, A5 minus A5. They're all 0. They all go away. And we're left with A6. So all we have to do is figure out S6 and S5, and then we're finished. So let's see. S6, we're going to put 6 in there. 6 squared is 36. 4 times 6 is 24. 36 plus 24 is 60. Plus that last 8 is 68. And then we will subtract off S5. 5 squared is 25. Plus 4 times 5 is 20. That gives us 45. 45 plus the 8 is 53. 68 minus 53 is 15, and we are done.